The first rule that we have for the exponential and the logarithm is the derivative of exponential function. The derivative of e to the power of u is equal e to the power of u du by dx. Du by dx. Example 1. If y is equal e power 3x, find dy by dx. So y, its derivative is dy by dx. If you wanted to find the derivative of any exponential function, you put down the exponential function as it is. And then you multiply it by the derivative of the numerator with respect to x. And derivative of 3x with respect to x is 3. So the answer is 3e power 3x. The answer is 3e to the power of 3x. Another example. If y is equal e to the power of sine x, find dy by dx. So dy by dx, the left hand side. I'm going to put down the exponential function, multiply the derivative of the numerator of the power with respect to x, which is cosine x. So the answer is cosine x, e to the power of sine x. Differentiate each of the following function with respect to x. F of x is equal e power 5x to the power 4. So f dash of x, or d by dx for f of x, is, if I have exponential function, I put down the exponential function. So I put down e power 5x to the power 4. Then I multiply by the derivative of the power, derivative of the exponent. And the derivative of 5x to the power 4, I put down the exponent, so it's 4 by 5 is 20. And subtract from the exponent 1, so it's going to be 20x to the power of 3. So the final answer for f dash of x is equal 20x to the power of 3 multiplied by e 5x to the power of 4. To the power of 4. Differentiate each of the following with respect to x. F of x is equal e to the power of 3x to the power of 5. And this is exponential function. So I wanted to find f dash of x, which is the same as d by dx, derivative with respect to x for the function. The derivative of exponential function, I put down the function, so e to the power of 3x to the power of 5, multiply by derivative of the power, or the exponent. And derivative of the exponent here is 15x to the power of 4. So it can be written as 15x to the power of 4 multiply e to the power of 3x to the power of 5. Differentiate the function with respect to x. F of x is equal e to the power of 5x squared. So f dash of x, or the derivative with respect to x for the function x, is, this is an exponential function, so its derivative is to put down the function, multiply by derivative the numerator, and derivative of the numerator is of the power or the exponent is 10x to the power of 1. So it can be written as 10x multiply e power 5x squared. Differentiate each of the functions with respect to x. F of x is equal e to the power of 4x to the power of 3. F dash of x or the derivative with respect to x for the function x is, we put down, as the rule says here, we put down the function, multiply by derivative of the power or the exponent, and the derivative of the exponent is 12x to the power of 2. So it can be written as 12x to the power of 2 e to the power of x to the power of 3. So 12x squared multiply e power 4x to the power of 3. Differentiate each function with respect to x. F of x is equal e to the power of 3x squared. F of x is equal e to the power of 3x squared. So I wanted to find the derivative of the function f dash, or the derivative with respect to x for f of x. It's the same. I put down the function and I multiply by derivative of the exponent, and derivative of 3x squared is 6x. So it's 6x e to the power of 3x squared. Differentiate each function with respect to x, So the derivative of the function, or the d by dx for f of x, is equal, I put down the exponential function e to the power of 4x squared multiplied by derivative of the exponent. Derivative of the exponent is 8x, so it's 8x e to the power of 4x squared. F of x is equal e to the power of 2x to the power of 3. e to the power of e to the power of 2x to the power of 3. So I wanted to find the derivative. So the same as the derivative with respect to x for f of x. So as we can see that the rule says that d by dx for e to the power of u is equal e to the power of u multiplied du by dx. So I'm going to put down the base. Multiply derivative of the exponent, and derivative of the exponent in this case is e to the power of 2x power 3 multiply derivative of the exponent, 6x squared. So it's 6x squared multiply e power 2x to the power of 3 multiply e to the power of e to the power of 2x to the power of 3. This is f dash of x, or the first derivative of x of the function with respect to x. F of x is equal e to the power of 5x squared divided by e to the power of 2x to the power of 4 minus 1. I wanted to find the derivative with respect to x. As we can see that I have here a quotient rule. This rule for the derivative of the exponential, but I'm going to write here the rule for the derivative of the quotient rule. Derivative of u over v is u dash derivative of the numerator multiply the denominator minus derivative of the denominator multiply the numerator, and squaring of the denominator. So f dash of x is equal derivative of e to the power of 5x squared. I put down the function, or the exponential function, multiply by the derivative of the power, which is 10x, multiply by the denominator a power of 2x power 4 minus 1. That all minus derivative of the denominator e to the power of tx power 4 2x power 4 minus 1 multiply derivative of the power, which is 8x to the power of 3, multiply the numerator, and the numerator is e to the power of 5x squared divided by e 2x power 4 minus 1 all to the power of 2, or squaring of the denominator. As we can see here that I have a bracket of e to the power of 2x power 4 minus 1 and another e to the power of 2x power 4 minus 1, and in the denominator I have e to the power of ex power 4 all to the power of 2. So I'm going to cancel one bracket here and there and from the denominator, so I can write it as 10x multiplied by e to the power of 5x to the power of 2, and cancel means that I'm going to divide each term by e to the power of 2x to the power of 4 minus 1 minus 8x to the power of 3 multiply e to the power of 5x square divided by e to the power of 2x to the power of 4 minus 1, and this bracket is power 1 right now. So this is the derivative of the function with respect to x. Differentiate each of the function with respect to x. F of x is equal e to the power of 3x squared multiplied by 3x power 5 minus 4. As we can see, this is a product rule, and the derivative with respect to x for the product rule is derivative of the first multiply the second plus derivative of the second multiplied by the first. So the derivative of the function is derivative of ex to the power of 3 is e to the power of 3x squared multiply derivative of the power, which is 6x, multiply the second 3x to the power of 5 minus 4 plus derivative of the second 15x to the power of 4 multiply the first e to the power of 3x squared. So as we can see, I can multiply this 6x, multiply the bracket here. So 6x multiplied by 3 is 18x to the power of 6 minus 6 by 4 is 24x. Multiply e to the power of 3x squared plus 15x to the power of 4 multiply e to the power of 3x squared. I can take e as a highest common factor, e power 3x squared as a highest common factor. So by taking highest common factor, e to the power of 3x squared, it's 18x to the power of 6 minus 24x plus 15x to the power of 4. This is the simplest form of the derivative of f of x with respect to x. Differentiate the function with respect to x. As we can see, we have a function f of x is equal 3x to the power of 3 plus 5 multiplied by e to the power of 2x squared, and as we can see, this is a product rule. The derivative of a product rule is equal derivative of the first multiply the second plus derivative of the second multiply the first. So the derivative of the function with respect to x, which can be written as the derivative of x, is derivative of the first 9x to the power of 2 multiplied by the second e to the power of 2x to the power of 2 plus derivative of the second e to the power of 2x squared multiply derivative of the power, which is 4x, multiply the first 3x to the power of 3 plus 5. Let's simplify it. I'm going to keep this one as 9x squared multiply e to the power of 2x squared plus 4x multiplied by 3 is 12x to the power of 4, and 4x multiplied by 5 is 20x multiplied by e to the power of 2x squared. As we can see, in both terms I have e to the power of 2x squared. So by taking highest common factor, e to the power of 2x squared, the remainder is 9x squared from the first term, and 12x to the power of 4 plus 20x from the second term. This is f dash of x, or the derivative of the function with respect to x. Differentiate the given function with respect to x. As we can see, the given function is a quotient rule, and the derivative of the quotient rule is a squaring of the denominator, and derivative of the numerator multiply the denominator minus derivative of the denominator multiply the numerator. So f dash of x is equal derivative of the numerator e to the power of 3x to the power of 4 multiply derivative of the exponent 12x to the power of 3. Multiply the denominator, 2x squared plus 1. Minus derivative of the denominator, 4x, multiply the numerator. Divided by squaring of the denominator, 2x squared plus 1, all to the power of 2. In the numerator, we can notice that I have e to the power of 3x to the power of 4 in both terms. And also, I can multiply 12x power 3 by 2x squared and 12x power 3 by 1. So, I can rewrite it as e to the power of 3x to the power of 4 multiplied by 12 times 2 is 24x to the power of 5 plus 1 by 12 is 12x to the power of 3 minus 4x divided by 2x squared plus 1 all to the power of 2. Differentiate each of the following with respect to x. F of x is equal x to the power of 4 plus 3 divided by e to the power of 5x to the power of 5. So this is a quotient rule, and the derivative with respect to x for u divided by v, a quotient rule, is v squared u dash v minus v dash u, derivative of the numerator multiplied the denominator minus derivative of the denominator multiplied the numerator. So f dash of x is equal squaring of the denominator multiply derivative of the numerator multiply the denominator minus derivative of the denominator, which is e power 5x power 5 multiply derivative of the power 25x to the power 4 multiply by the numerator x to the power 4 plus 3. This one can be simplified as I can divide each term by e to the power 5x power 5, e to the power 5x power 5, e to the power 5x power 5. So I can cancel one term from each term, and I mean by cancel, I can divide here by e x power 5, and here e power 5x power 5, and here e power 5x power 5. So the remainder in the first term is 4x to the power of 3 minus 25x to the power of 4 multiplied by x to the power of 4 plus 3 divided by e to the power of 5x to the power of 5, only to the power of 1. I can simplify more by expand this bracket. So I can write it as 4x to the power of 3 minus 25x to the power of 8 minus 75x to the power of 4 divided by e to the power of 5x to the power of 5. Differentiate each of the following function with respect to x. F of x is equal to the power of 3x to the power of 3, and we know that this is a derivative of exponential function. Its base is 2. So f dash of x, or derivative of the function with respect to x, is equal the same function 2 to the power of 3x above 3 multiplied by len the base, which is 2, multiplied by derivative of the exponent, and derivative of the exponent is 9x squared, and that's it. If there is no any kind of simplify, you can do it in this question. Differentiate each of the following with respect to x. F of x is equal 5x to the power of 4, and here is the rule to the right that the derivative is equal a to the power of u multiply the len of the base multiply the derivative of the power. So f dash of x is equal, I put down the function 5x to the power of 4 multiply by len the base 5 multiply by derivative of the power, and derivative of the power is 4x to the power of 3. Notice that you cannot multiply this 4 by 5.